In this video, I'm going to look at some refactoring I did on the actual ESP32 probe program. I changed the output. It was called probeEvents. I've changed it to measurements, but beyond the name, it actually changes how I output probe information. So with measurements, I could have multiple measurements for one probe. So for example, for Bing, I have a bits per second and a round trip latency measurement. So they're both outputted as measurements, and then the name measurement just made more sense. So I did that refactoring, did a little bit more refactoring around sort of the flow through the probe. So I'll walk through that. It's actually going to be this flow chart. I'll go through that after the introduction, and then also have a look at the middleware I put in place to communicate between the Angular client and the Cloud IoT backend. So I've got it going two directions, collecting up the measurement data, putting it into a Firestore database, and the other way responding to Firestore triggers to update Cloud IoT, and also look at utility function I put into the Angular client to make the config file for a particular probe, just to make configuring probes a lot easier. So let's get going and see what it looks like. So I changed on the ESP32 the actual Python program main.py. This is the new flow through that program. This was the old one, so you can see as well as the diagram looking a bit better. The main change is down here in the results. Changed it from outputting results to outputting measurements, and more than just the name change. What this allowed me to do is for one probe activity it could output multiple measurements, and also makes it a bit more generic, so I can collect measurements other than just the predefined probe measurements. So let's have a look at the new flow through this. So the ESP32 powers up or reboots. First it'll read the config.py. I'm also going to, in a future one, add in some logic to look on the SD card on the ESP32 gateway to see if there's a new config.py, and copy that over as a way to get configuration information, or the initial device configuration information onto the ESP32. Then it connects to the network either through Wi-Fi or through the Ethernet connection. Gets the network time protocol time to get the exact time. Sets up the Java web token. Then it calls a subroutine called MQT process config and measurement. So it basically does what the name says. Does an MQT connect. Gets the probe config JSON as part of the information that comes down from Cloud IoT, and sends any measurements that are in the measurements folder here. So initially after boot up there shouldn't be any measurements in that folder. Then while the Java web token is valid, and that's one of the config parameters from this config.py, usually is set up to, I think, be valid for half a day. So while it's in this loop, so over that half day, it will continuously perform network tests. So it reads the probe config information about what tests it should perform, bings and availability and things. And as it runs those tests, it's going to put the results into the measurements folder. Once it's run through one set of the tests, then it's going to call the subroutine again. It'll get the latest MQTT or the process config information, but importantly it'll now send the measurements that it just collected here up to Cloud IoT, and then finally it will sleep for the remainder of the governance seconds. So say if it's set to 500 seconds, or sorry, 300 seconds or 5 minutes, and then depending on how long it's taken to do this initial part will be the remainder seconds that it sleeps, and it goes around and does the same thing again. Once the Java web token time is expired, or just before it expires, it's going to end this loop, and then it's going to do a reboot on the ESP32, and that's just to clean things up on the device. I wasn't sure whether it could run for
years and years without sort of sanity checking with a reboot, and also timing's not that important. Having a reboot process happen periodically is not going to mess up any timings with running probes, so this is a good way of just making sure that the memory's cleared up, there's nothing hanging around, there's not any problems with garbage collection where I've got items just hanging around in memory, or were put in a weird place for one time that fouls up the whole process. So it does a reboot and goes through the power up and things again. So I'm going to have a quick look at that in code, and then go over and have a look at the middleware, which is kind of a different subject, which happens up on Google Cloud Firebase functions. So looking at the code, so this is the ESP32 Python code. So I'm in the main routine. I won't go through main. I think I went through that in an earlier video, but just look at the changes here as part of refactoring. So like I said, I've put the MQTT process config and measurements into a subroutine because I call it multiple times, and it's basically doing two things. It's doing a garbage collection just to clear up the memory, then it goes out, connects to the MQTT host on Cloud IoT, checks for any new messages, so any more new configuration information from the Cloud IoT, and saves it in Cloud and probe config variable, and then it runs through the measurements folder on the ESP32. So as I said in the overview, as the probes run, they output measurements, so it runs through the measurements that have been collected, and for each file it gets that file and sends it up to Cloud IoT, loops through deleting those measurements as it sends them up so that the folder gets cleared out. Then it disconnects the MQTT client and returns the probe config to the main program. And then just jumping over to the main flow through main.py, so it does when it first starts up, it clears out the measurements folder, sets it up if it doesn't exist, does a network connect, gets the network time protocol time, so it's got the exact synchronized world UMT time, gets the IP, gets the JWT expiry time from the config.py configuration information, creates the Java Web Token JWT, and then it goes into a loop. So until that Java Web Token reaches its expiry time, I think usually by default I set it for about half a day, then it's going to keep looping through this main loop. So the two main things it's doing is first running all the capability tests for the probes that have been assigned to this device, and at the moment only the Bing capability test is set up. So here you can see the change where for a Bing you get two results. You get the bits per second bandwidth between the probe, or between the device and the target, and you also get the round trip latency. So I'm saving these as two separate measurements. So this is the main refactoring change. Also, when the capability test, in this case Bing, fails, it doesn't send any results back. So before I was seeing a result back saying that it didn't complete successfully. Now I'm just not sending any results back. That seems to work, makes doing statistics a lot easier, and we still get the same results. So over time we can see if there's a missing metric over time, like the metric count for say over an hour is lower than normal, then it tells you that there was some problems with availability. So we get to the same result as far as being able to report things. Then we do the governance action. So just works out how much governance time is remaining, and we'll sleep for that time, and then finally do a new MQTT process config and measurements to get the latest config again, as well as sending the measurements up. And it'll do that loop, like I said, until the Java Web Token expires. When that happens, then it's going to go down here and do a machine reset, which essentially acts like a new power on event. So it refreshes the whole device and starts from scratch again. Again, that only happens every Java Web Token expiry time, so about twice a day. This video was getting a bit long, so I've moved the discussion of the middleware and the middleware code over to ourProbes24 video. So jump over there to see the continuation of this.